Okay, so do you guys understand what's going on with this one? With Greg and his fitness program. Greg started a fitness program 6 weeks ago. Okay? Right now, he's been working his way up. He's been doing more and more every week. Right now, after 6 weeks of doing this, he can jog 35 miles a week. He's been adding 2 miles per week, every week for 6 weeks. So, similarly to the last problem, if I want to write an equation that models his weekly mileage in terms of the number of weeks that he stays on the program, I should backtrack and figure out where he started. You with me or not so much? Yeah? So right now he's jogging 35 miles a week. He's been adding 2 miles every week to this for 6 weeks. So where did he start? You do know. He's been adding 2 miles a week for 6 weeks. So how many miles has he added on, Drew? Yeah, 2 miles a week for 6 weeks. So he's added on 12 miles from where he started. So if he's at 35 now, where'd he start? That's it. So the guy started at 23 miles a week. And then he added on 2 miles per week. There's your equation in part A, right there. Just change my words into math. If the guy's adding 2 miles a week, and he started at 23 miles, that's an equation. I know they say M and N. I don't care for M's and N's. Who thinks they have it? Nobody? How many miles is he adding every week? 2. So in math, isn't that just 2x? That's it. Not 12 though. 23, because 23 is where he started. So before he started this program, he could do 23 miles a week. Then he started adding 2 miles every week. Does this make sense? Is everybody okay where we got 23 from? All right. Now in part B, if he's going to do this for 10 weeks, where is it going to end up? 43, right? Because I would just pop in a 10 for x. So 43 miles. Good job, Greg. Sure. 5 is a bit different. So let's see if we can work our way through 5 together. So this says, at sea level, the speed of sound in air is linearly related to the air temperature. If it is 35 degrees Celsius, sound will travel at a rate of 352 meters per second. If it is 15 degrees Celsius, sound will travel at a rate of 340 meters per second. Write a linear equation that models the speed of sound S in terms of air temperature T. What in the world? Oh my gosh, this is so confusing. It's not once you realize that all they've done is give you 2 points on the line. That's it. If I give you 2 points, can't you write the equation on the line? Forget that it's a word problem. If you just glance back at your quiz, look at number 8. I just gave you 2 points and you came up with the equation of the line. Number 7, I gave you 2 points. You wrote the equation of the line. Number 5, I gave you 2 points. You wrote the equation. If I give you 2 points, you can write the equation. That's all they've done here in just a really confusing, wordy way. They've just given you 2 points. Look right here. Here they are. Let's see. I'll use this as my highlighter. 35 degrees Celsius gave me 352 meters per second. That's a point on my line. 35, comma, 352. 35, 352. The other point is just the other bit of info they gave me. 15, 340. Is everybody okay so far? So now that I see that they're just 2 points on the line, what do you do if you have 2 points and I have to write the equation? You gotta find the slope. So 340 minus 352 over 15 minus 35. And then I just do the math. Okay, I have the slope. Now what do I do? Remember what my directions are. Write a linear equation that models the speed of sound s in terms of air temp t. If you want to replace the s with an x and air temp with a y. Or if you like using s and t, I don't really care. Yep.
You'd use the, what's it called? It's like y plus y.
Y minus y1?
Yeah.
Point slope form, you're right. How do you know which point to use?
You can use anything.
Either one. I'll use 15, 340 just because the numbers are a tiny bit smaller. So y minus 340 equals my slope is 3/5. X minus 15. Guess what else? Look at the directions. It says write a linear equation. You can leave it. It didn't say it had to be in slope-intercept form. It didn't say it had to be in standard form or anything else. It just said write a linear equation. Well, this is a linear equation. You don't have to change it into slope-intercept form if they don't ask you to. Don't. Why do extra work? You can still answer part B with that equation. Part B asks, how fast will sound travel at sea level if it's 25 degrees Celsius outside? So what do I do with 25 to get my answer? That's it. So I'll just do y minus 340 equals 3/5 times 25 minus 15. Remember that you have calculators at your disposal, but make sure that you're doing order of operations first. You should do whatever's inside the parentheses first, then multiply by 3/5, and then I'll add that 340 over, and I'll be done. So 25 minus 15, of course, is just 10. 10 times 3/5 is just 6, and then add 340 over. 340 degrees, wait, that's the speed, sorry. Meters per second.
346.
Oh yeah, that's what I meant. Thanks. And then C, you already know the answer to. If sound travels at 346 meters per second, what's the temperature? You know it. You don't even have to do any math. You know this one. Yeah, unfortunately they use the same number as you just got as your answer. So yeah, if it's going 346, I already know it's going to be 25. Can we pretend that that was something else? Because I don't think they meant to give you the same number. Let's change that to let's change it to 400 meters per second. So let's just pretend, I don't know how this is going to come out, if it'll be nice or not, but if sound is traveling at a rate of 400 meters per second, let's see if we can figure out what the temperature must be. So what am I going to do with 400? Where do I put that? If I'm looking back at my equation, where am I going to put 400? Yeah.
In place for the 340. No, 300. Yeah.
Like replace that 340?
Keep it down.
You're close. They're not going to replace that guy. I'm only allowed to replace X's and Y's.
So you put it for the Y.
Yes, I just put in 400 for Y and we can solve for X. Right? So now I'll do 400 minus 340 equals 3/5 times X minus 15. And now I just have to solve for X. Okay, so we can do that. 400 minus 340 is just 60. Let's distribute that 3/5, shall we? Do you remember how to do 3/5 times negative 15? Do you remember how to do it so fast? I hope you're not doing 3 times 15. Fast, yeah.
15 divided by 5 plus, or no.
So you were right. 15 divided by 5, that gets me 3, and then I multiply it by the top. 3 times 3 is just a 9. Divide down, multiply up. Divide down, multiply up. And now what are you going to do to solve for X?
Add the 9 to the
Sure. And now what? You got to get X all by itself. What am I going to do? You have 2 options here. What were you saying? Divide by. So when I divide both sides by 3/5, it's the same thing as. How do you divide by a fraction? Aha, you multiply by the reciprocal. So those are gone. This 5/3 times 69, you can just do 69 divided by 3, which is 23 times 5, 115. So if the sound is traveling at 400 meters per second, that means the temperature is 115 degrees, what are we in, Celsius? Woo! But that's it.